Hello everyone and welcome back. My name is Mr. Kovalt, and in this video I'm going to be going over how to determine the range of possible values for measurements. So let's get into this. So when they're asking you in a question to give the possible range, what they're really kind of asking you is to determine the uncertainty of the measurement, right? So the thing you got to remember, and this is key, that the uncertainty of the measurement, unless you're told otherwise, it's assumed that it's plus or minus one in the last digit of your measurement, right? And so then the range is going to be from the highest level, which is when you add one to that last digit, to the lowest level when you subtract one. So anywhere in between those two is going to be the range of that measurement within the parameters of error, of uncertainty, right? That's what they're really getting at in this sort of question. So let's apply this. So in A, we're given a measurement of 1.98 meters. So that there's going to be some uncertainty, some error involved in that measurement based on the measuring tool that you're using, right? So in this case, again, if we're not giving any information about the uncertainty or precision of the measurement itself, then the assumption here is that the uncertainty for this measurement is going to be in the last digit plus or minus one. So it's either going to be plus one in that last digit or minus one in that last digit. And so that's the precision. So the precision for this one, if we're going to do the precision, then the precision for this is going to be plus or minus one in this digit right there. But that digit is in what place? It's in the hundredths place. So it's going to be plus or minus 1/100th of a meter. So the way we write that is going to be plus or minus, oops, that's a bit long for a minus. So I'll do it this way, plus or minus 0.01. So that's the precision of this measurement here. It's either going to be plus 0.01 to that measurement, or it's going to be minus 0.01 of that measurement. And so what happens there is that gives us a range. So then the highest value within that range is going to be when we add plus 0.01. So if I add 1 to the last digit, what does that become? It becomes 1.99 meters. So the highest value in the range is going to be 1.99 because I added 0.01 meters, let me put meters there, to the value. So that could be the highest value. The lowest value is when I subtract 1. So if I subtract 1 from the 8 here, then that's 1.98. Or in another way to put it is from the measurement, I'm subtracting 0.01, which means that the 8 drops down to a 7. So then the lowest value in the range is going to be 1.97 meters. And so basically, my measurement, let me fix this. My measuring tool allows me to have a range of measurement for whatever length this is measuring. I can be within a range of 1.99 and 1.97. If I fall outside that range, then that measure would be there'd be some sort of error beyond that. It would be outside the range of possible allowed error. So that's what that's really getting at. So that's this here. So let's go to B. Now this one causes difficulty for a lot of students because they look at this and they're not sure what to do with this. And the reason is because this is written in scientific notation, and so that's going to throw you off. And so why is it going to throw you off? Because you have to know where the precision is. And as I said, the precision is going to be plus or minus 1 of whatever the last digit is. And you got to know what place that digit is in. So here, the last digit is the 6. Now, you might look at this and say, okay, well, it's plus or minus 1 where the 6 is. What place is this? Well, it's 1, 2, 3. It's the 4th decimal place over. So you might assume that the precision for this measurement is plus or minus 0.0001. Because the 1 is in the 4th place after the decimal, because my last digit is in the 4th place after the decimal. So you might think, oh, it's plus or minus 0.001, just like the last digit here is in the hundredths place. It's the 2nd decimal place over. So therefore, it's plus or minus 1 in the 2nd place over from the decimal point. That is great reasoning, and it's makes sense, and it's understandable why you would say that, but you would be wrong in this case. You're not wrong in saying that the precision is in the last decimal, plus or minus 1, but you would be wrong in where this 6 is. What place does this have? And that's because you're ignoring the 10 to the negative 28. When this is written in scientific notation, if you go back to remember how we got scientific notation, we got scientific notation by taking the standard form of the number, the standard notation, and what did we do to the decimal point? We moved the decimal point. So this decimal point is not in its proper place. We moved it over in order to write this in a more succinct form, in a contracted form, right? So in order to get the actual place of this 6, I would have to write out the number. I would have to move this decimal point over this way 28 times. And then I'd have 27 zeros followed by 91096. That would be too long. That would be a very long number. And so there's an easier way to do this, a shortcut, if you will. So the way you want to do this is we want to know what place this is, and we're going to take advantage of the times 10 to the negative 28. So we move the decimal point this way in order to get negative 28. So we moved it over 28 times. Well, if you want to know what place this is, what the precision is, right, then you just keep moving the decimal point over to the right of the last digit. So what you do is, okay, I'm going to move this over. It's going to be 1, 2, 3, 4. I moved it over 4 more times. And remember, when you move it over this way, then you make the exponent here, the power negative. Well, if I move it over 4 more times, then I got to make this 4 more times negative. I got to add 4 to this. So I'm going to add negative 4. So what is negative 28 plus a negative 4? That's going to be a negative 32. So then that becomes 10 to the negative 32. And that, ladies and gentlemen, is your precision, plus or minus 10 to the negative 32. So that is a short way of writing the precision. So it's plus or minus 10 to the negative 32, in this case, grams. Or if you wanted to write it out it would be plus or minus 0.000. So you write 31 zeros and then a 1 after that, right? But we don't want to do that. This is a lot easier. So that's the precision. That's how you find precision. So anytime you're given scientific notation and you want to know what the precision is of your number, move the decimal point over to the right of the last digit, count the number of times that you have to move that decimal point, and then add that number negative times. So that number is going to be negative. Or you could, another way of thinking about it is subtract that number from your exponent. So here we have a negative 28. So if I was going to subtract 4, so negative 28 minus 4 gives me a negative 32, right? If this was a positive number, then I would do 28 minus 4, and then that would give me 24, or positive 24. And then that would be my precision, plus or minus 10 to the 24. But here I'm given a negative. This is a negative 28. So negative 28 minus 4 gives me a negative 32. So that works with any number written in scientific notation. Okay? So now is the easy part. Oops. Sorry about that. So now is the easy part. So just like here, I can figure out what the highest value and lowest value is by adding and subtracting 1 from the last digit. So for this case here, right? So I'll put that up there. For the highest value, again, I'm going to add 1 to the last digit. So this is the last digit, 6. I add 1 to that. I get 9.1097 times 10 to the negative 28, or negative 28. So this 4, it doesn't get added. I'm just taking the original number with the original exponent, and I'm going to add 1 to the digit. So this becomes 9.1097 times 10 to the 28, negative 28, and that's going to be grams. So all I did was add 1 to the last digit of the original measurement. Okay? Then for the lowest value, same thing. The lowest value in my range is going to be where I subtract 1 from the last digit, and that's going to be a 5. So now it's going to be 9.1095 times 10 to the negative 28 grams. And there's your range. You've got the highest value to the lowest value. So your measuring tool can give you a value within that range in order to be within the realm of error, to be within those parameters of error. If you're outside that, then you've got too much error and you can't really use that data point. Okay? Last but not least, here's an easier number, no scientific notation. So again, if this is the measure in grams, the precision, unless you're told otherwise, you assume that the precision is going to be plus or minus 1 in the last digit. Now here, the last digit is in the ones place, so my precision is going to be plus or minus 1 in the ones place. So if I write the precision, that again is going to be plus or minus 1. And since the last digit is in the ones place, it's going to be plus or minus 1 gram. And so now when I figure out the range, I'm going to add a 1 and subtract 1 from the last digit. So the lowest value, the highest, we'll do the highest first. The highest value is going to be 1 added to the 2. So it's going to be 613. So 613 is going to be the highest value, and the lowest value is going to be where I subtract 1 from the last digit, and that's going to be 11. So the lowest value is going to be 611. So 611 grams. And again, that's the range of my measurement. These are the range in which my measurements can fall according to the precision of the tool that I use to get this mass. And that, ladies and gentlemen, is how you find precision and range of your measurements. So I hope this video was helpful. If it was helpful, please like the video, share the video, hit that like button over there. Also, make sure that you subscribe to my channel, hit that notification up there somewhere. When you do, make sure you click the notification bell. When you do that, make sure that you click all so you can be notified by all the videos I put out. And finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have any questions that you need help with, please put that down below. If you have a topic you want me to cover, let me know, and I would love to do that for you. Thanks for joining me, and have a great day.